So hello everyone, this is session number 29 and today we are going to start with solid edge weldments. So today we are going to make some standard weldments. We are going to make a simple table there seeing all the commands of weldments. What are the modifications, how to start a drawing, how to make 3D sketch as well as 2D sketches and how to apply the structures. Other than structures we also need some support plates and all like end caps, ribs, bottom side support plates. That parts we are going to make in part model and we are going to assemble them in weldments. As I am using the term assembly, it means weldments interface is nothing but assembly interface only. Just thing is that we are going to make 3D sketch there. We are going to apply standard structures and for the manufacturing parts we are going to assemble the parts by making them differently in part modeling. So to start with, I'm going to take a Weldments. First, I'll close this interface. So we have to go in new and we have to select isometric Weldments. As I have said, it is nothing but assembly interface only. You can see here, insert components, whatever we have seen in assembly playlist. Here are the mates. Here is the option for drag and move. All the things are same as assembly interface only. You can see the symbol is different here. So in this symbol, one orange line is being shown, showing that parts are being welded here. Instead of saying assembled, we are going to say that the parts are going to be welded together. If I take the assembly interface, you can see the icon there. Suppose if I say new and I'll say isometric assembly. So in assembly interface, this icon is little bit different. Instead of orange lines here, you can see the orientation of these three boxes has been reversed and there are three blue lines. So this icon represents assembly of solid edge. And this icon you can see here three boxes, simple boxes in 2D with orange line represents the weldments. So we'll start with the weldments now. For that we are going to make sketch first. So to start with we are going to go on tools, environments, and in environments we can say a frame. So in frame you will get the option sketch, 3D sketch, frame option. So these are the things we required here for the weldments. So we'll start with the sketch first. I'll take this sketch. I'm going to say top plane here. We'll hide the planes here and we are going to make one simple rectangle with center rectangle. Now as the structure sizes are little bit larger, I'm going to take the values little bit more here. So we'll take this value here as 600 mm and we'll take this one as 290 mm. Next we are going to make some more lines here. We need to have equidistant this line. So for that I'm going to say symmetric. I use this as a symmetric axis. Select both these two lines here. We'll take this distance as 250. We'll modify it. I'll say 200 only. Say close sketch. Next we need to make the table legs. So for that I'm going to use 3D sketch instead of 2D. So I'll take this 3D sketch here. We are going to select the line. Start with the line. And now as I click on the line command, you can see one small axis system is being shown. We'll hide the reference planes. You can see this axis system here. But when I click on the line, one more axis system will appear here with larger size. You just need to select the axis on that particular axis system so as to define the directions of the sketch. So as soon as I click on this line, you can see here this axis system has been appeared. If I start with the line here and select Z axis, you can see with the line Z icon is coming, representing that line is coming along the Z axis. We'll repeat the line here. Select the line, select Z axis. We need four lines here on all four corners. In between we are not going to take any line here. Next we need to say equal relation. And we need to apply the distances also. So we'll take this distance as 320 mm. We'll take one more line along with x direction. So we need to select the x direction here on this bigger axis system. Now you can see one red dot is coming on this line intersection, but on this line intersection there is no dot. Means this line is not properly connected to the vertical line. So for that I'm going to use the relation also here. So in 3D sketch also you have the relations option. You can draw circles, rectangles, arcs. So for that I'm going to say connect this type. So you can see this dot has been appeared in red color showing that the line is coincided with the vertical line. Next we need to apply the distance. So I'll select this horizontal line and this end point. I'll take this distance as 100 mm here. We'll make this length little bit smaller. I'll take it 280 only. This is enough now. Next one more line on the other side. We'll take the same distance as 100 mm. But you can see this line is not defined. It is because it is not been taken along the x-axis. It is little bit inclined. So I'll delete this line again and repeat the line command. Just click on this x-axis and you can make sure this line is coming at along x-axis. So here we need to make them coincide. Then apply the distance. You can see it is completely defined now. Same way I'm going to make lines at y direction. So I'll take the line command again. We need to select y axis and then select the position for the lines. Provide the relation here. Say coincide. We'll also provide the dimension again. So this dimension I'm going to take as 80 mm. We'll make the line on other side also. For that I'm going to select line. Select y axis for the reference. And here this line has been made. Just need to provide the coincide relation. It is very important that line should be connected to the other lines so as to apply the proper structures without having gaps. We need to provide the dimension next. So at this side also I'll take 80 mm. Now this sketch has been made. So this is the 3D sketch. We'll hide the axis first. We'll also hide the coordinate system. So now you can see here. In this case we have made this upper side, that this rectangle can be seen in top plane, and these two lines are made in 2D sketch and all the lines, remaining lines, are made in 3D sketches. You just need to select the axis system for the reference. So all the relations and sketch commands were available in 3D sketch. We have just applied and made this complete structure here. Next we are going to apply the standard structures. For that we need to close the 3D sketch, and here we have this option frame. So in frame we'll get all the standard structure shapes such as square tube, rectangular tube, circular tube, C-channel frame, I-section beams, and much more. These frames will have some standards also, we'll see them together. So to start with I'm going to select this option. So in Weldments there are total 3 options. If we go through depth of this all 3 options, we'll almost understand all the Weldments. So that options are select path step. This is the first option. With the icon here, you can see this line icon with zigzag lines. Second option is edit cross sections, in which we are going to edit the cross sections. Third is the end condition, in which we are going to apply the end treatments. If we go through all these options, we are almost done with the Weldments. So first we'll start with the select path step, in which we are going to apply the standard structures on the sketch. We need to browse the components there. For that we are going to select this icon, yellow color icon, showing that select cross section component. Click on this icon. You will get 3 standards here: NC, DIN and extrusions. So we are going to start with DIN here. We don't have ISO standard system in this. That's why most of the companies don't work with the standard structures. They just make the parts. Standard structures also they are going to make in part model only, and they are going to assemble them directly. They are not going to apply the standard structures. But as we have the standard structures option, we are going through that. So to start with, I'm going to select C channel here. So in C channel we are going to select the size 40 by 20. Say open. After selecting the size, you can see This channel is been displayed in this frame here. Now we need to select the lines on which we want to apply the C channels. So I'll select these lines here. First, you can select the lines in chain option also, but I am taking single here. First, second, third, and this is the last one. Say OK. So you can see here, C channel has been applied. It is oriented at the downward side with the opening side. That's why we cannot see it properly. So we'll take this orientation with 90 degrees angle. For that we need to go for the second option. We are going to say edit cross sections. So in edit cross section you just need to select the option, say OK, and here you will get three most important commands. First one will be the orientation. If you want to make this C channel orient at some particular angles, you can go for this orientation option by giving the angle. Second option, the most important option, is refine handle points. We will see that also. And third one is this flip cross section. So if I want to flip the cross section, I can flip the cross section after providing the angles. So we will see the first option, that is orientation angle. We'll provide this angle as 90 degrees here. So you can see this frame has been now oriented with 90 degrees angle. As it was horizontal first, now it is showing vertical. It is because we have provided the angle as 90 degrees here. In corners also you can see the C channel profile now. This makes us understand the shape of the channel we are using. At downside we are going to say flip cross section. So now the C channels are coming at the outer sides. You can see here this opening is coming at the outer sides with the wall at the inner sides. So we have provided the angle here as 90 degrees. We have also flipped the cross section so as to understand the channel shape. Next we are going to go for the handle points. Just select the handle points and you need to go and zoom it here. So at each corner you will get this handle points. Total 9 points are there in red color. So at whatever point I am going to click, that point will be grabbed by the sketch. And all these C channel sections will move along the point. So if I say this bottom point, it will get stuck on the sketch and this complete C channel will move at the upward direction. So I'll select this corner bottom side red dot to move the profile. So you can see all these structures are now coming at that particular point and this complete profile is being moved at the upper side as we have selected the bottom dot. If I want to take this profile at the lower side, completely at the downside, then we are going to select again the define handle points. And now this time I am going to select this point, that is the upper side. If I select the upper side, this complete profile with all four structures will move at the downside. You can see here. If I want this structure to be positioned at downside only, but at the inner sides of the sketch with reference of this line, this 2D sketch we have made, then again we'll say define handle point and we are going to select this outer point so as to make them move in inner sides. You can see now all the complete structure is coming at the inner sides of the 2D sketch. If I want this structure to be divided on both the sides equally, this upper width of the C channel, again we'll say define handle point, and for that we are going to select this midpoint. So this midpoint will get stuck at this corner. So I'll select this midpoint now. So you can see this C channel is coming equally divided on both the sides of the line or corner. If I select define handle point again and select the midpoint, so this corner will come totally at the center of C channel and this complete structure is being applied now in this way. You can see here. So these handle points are used to move the structure along the points which we have provided here in red color marks. So this were the options in edit cross section. I'll say finish here. Next, if I want to change the C channel and if I want to take rectangular tubing instead of C channel, I'll just go in model tree, click on this drop down menu, select the frame option, and we are going to select this edit cross section. Select this edit command, and to call any cross section we need to select this red color mark, select path step option. Here we'll browse the file again to change the option. So I'll say DIN and rectangular tubing. So in rectangular tubing I'm going to select the standard, that is 50 by 30 by 2.6 length, width and thickness. These structures are provided by Solid Edge itself in the library. We are just going to select the structure from the library and say open. Now if I say OK, it will ask some segments in this feature will have different cross section. Say it yes, and you can see this rectangular tubing has been updated. It is coming a little bit larger in size. So I'll take smaller size. Again, I'm going to select this select path step option. Say browse, say DIN, rectangular tubing. We'll select this size as 40 by 20 by 2 only. Say OK. Again OK. Say yes. So now this size is a little bit smaller and the orientation is coming here as horizontal. So if I want to make this rectangular tubings stand at 90 degrees instead of being horizontal, we will orient it vertically. For that we are going to select edit cross sections. As we have seen, we can edit the angles for the orientation here. We'll say it OK. Then we are going to orient this. Again I'll say 0 degrees here. This orientation is coming now at vertical direction for the rectangular tubings. Say again 90 degrees, it will become horizontal. Say finish now. Next we are going to see the corner treatments. So you can see this corner treatments. We can see these joints are miter joints. They are connected at 45 degrees here. Suppose if we don't use standard structures and if you want to make this structure, then in part molding you need to make this structure. Same with the 45 degrees angle cut, and then you need to assemble it in weldments. So the next option is if I want to edit the end conditions for the cross sections. Instead of miter joint, I want butt joint here. For that again I am going to select the frame options and say here edit end conditions. If I say edit end conditions, this was the third option. So this is the last option out of the three options which we said were important. Select that option and here you will see the corner treatments. So instead of taking this miter joints, I'll select this option, that is frame option, and I'll set this as a butt joint. You can see the note is coming showing that this joint is butt joint. Select that option. You will see this preview also showing the differences. If I say miter joint, you can see these corners are 45 degrees connected, and if I say butt joint, these corners are now connected with butt joints, overlapping and underlapping. Two sides underlapping, two sides overlapping. Say apply and OK. So you can see here these two vertical tubings are now underlapped on both the sides at top side and bottom side, and these horizontal tubings are overlapping here. These two sides are underlapping and these two sides are overlapping. Say finish. If I want to change the end condition and reverse the conditions here, I want to make this vertical tubings overlapped and this horizontal tubings underlap. We'll go for the option and select again the end conditions option. As soon as this frames option appear here, we are going to change the access system. At present this access system has been activated. You can see this blue colored icon. I'll click on this option. After clicking, you can see here the orientations are being changed. Again, if I say the first one, observe this preview. These green colored lines are overlapping and these white colored tubings are underlapping. If I say the second option, it will reverse the condition. These green colored lines will overlap and these white color lines will underlap. So here are the different end conditions in the access systems. I'll change this and say apply and OK. You can see the change now. These vertical tubings are overlapping and the horizontal tubings are underlapped. Say finish and cancel. Now we need to see one more difference. Suppose if I select this frame option and go on this option for the end conditions and select this option, then this will select all the corners. But if I want to edit individual corners, I'll select this option and just say OK without making any changes. And if I want to go for individual edits of the corners, then after saying OK, this frame options will again appear for the second time. You can see this chart. And here I'll select the end condition. Instead of selecting the end condition from the frame directly, I'll say OK and then here I'll select the end edit conditions. You can see this red colored dot will appear here at all the four corners, representing each corners individually. So now if I want to edit only this right side two corners, I'll select both the corners. This color of the dots will change in green color. Say it OK, representing that only these two dots or these two ends will be edited. This will remain by default setting only as we have applied earlier. So I'll say OK, and we are going to edit only these two end conditions. So for that I'll say miter joint. So you can see here this miter joint end condition is applied only on those two corners, but not on these default corners as we have selected only these two dots here. If I say but again, it will take but. If I want to change the preferred condition of the axis, you will get that option. You will get that axis option here also. So I want x axis or else I want y axis. As soon as I click on this y axis, you just need to observe here. This tubing will overlap and the horizontal tubings will get underlapped. So I'll select this y axis. You can see there this is overlapped and these two are underlapped. Again, if I want to change the axis preference, I again go for x axis. It will go as it was earlier. If I want to apply the weld gaps, I'll select on this option and you can see here this gaps option is coming. You want to apply the value for this gaps, you can apply the gaps value also here. So I'm taking 3 mm gap. If I want to put off the condition, I'll again select this but and put off this option. I'll say 0 without any gap. We'll see these options also later. We just say finish. So now these two end corners are individually customized. Now if I want to remove this override on the end condition and make them as default condition same as left corner, then I'll select this option and go for this option end conditions. And now this time I don't say OK, I'll just say clear overrides. As soon as I say clear overrides, it will show that two corner overrides will be removed. Just click on this option. It will show this cleared over treatments of two end corners. I'll say it OK. And as we have cleared the end conditions of the overrides, these angles were also overrided. So they were also removed. And the orientation of tubing is coming vertical. So if I want to make this orientation default instead of overriding the angles, I'll select this orientation from this chart itself, that is from frame options. So earlier we have selected the orientation as customized for individual corners. This time I am selecting this condition from the frame options itself. So I'll apply this angle as 90 degrees from here only. Say apply. And you can see the end conditions are now making the pipes horizontal orientation. Again here we have some more options. Suppose if I want to go for the end treatment as radius, I'll select this option. You can add the value for the radius. I'll say it as 40 mm radius. Say apply and OK. So now you can see these corners are being treated with the end condition as radius. That's why these are showing as circular here. So this is the standard structure, straight structure from here to this edge. And then you have this separate part from this edge till this edge. You can see the partition lines here. And then again you will continue with this part, that is straight one, and continue with the arc portion on the all four sides. Say finish. If I want to again change the condition, select the frame option and select this option, that is edit cross sections. This chart will appear. We will say this condition now as overlapping condition, in which we can provide the overlapping treatment. I'll take it as 150 mm overlapped, apply and OK. So in this condition, the structures will overlap each other with extension dimension as 150 mm. Whatever dimension you put, you can overlap there. If I want to again change the end condition, then say finish and go for this frame option, and here you can change the end condition. Instead of that, I'm going to say no corner treatment, apply and OK. So here you can see corners are not being shown. The structures are coming only to the length of the line. You can see here. Now if I go for this option for editing, it will take individual customization. And if I say finish and then go for the same option by selecting the frame here, you can see all the three options again here. This will change the end condition and corner treatments default only. So you have both conditions. If you want to change the corner treatment, by default you select the frame option and then go for this option, or else you just select any one option, say OK, and here you can go for these three options again, but this time this will edit individually, not for all the default corners. I hope you understand both the differences here for the selection. We'll go for this end condition again and we'll change it and say apply corner treatment only and miter corner frames. Say apply and OK. Next, we are going to apply structure for these two lines as well as for the vertical lines here. So to start with, again I am going to select frame option. Say square tubing 30 by 30 by 2.6. If this option is not coming, we need to browse here. Select DIN folder. In DIN, I am going to select square tubings and here you will get that option. So I'll take this size here as 20 by 20 only now. Say open. Thickness is 1.6. We just need to click on the sketches where we want to apply these tubings. Say OK. And you can see the square tubes are being applied at the corners. Now even if this sketch was connected from end to end, the square tubes are being getting by default trimmed and they are being adjusted within the gap of this structure according to the size of the gap. But if we observe from the top side, I'll orient it little bit and I'll make this part transparent. These square tubings are not coming at the corner point of the sketch. Earlier rectangular sketch, this corner point you can see here. These tubings are not mounted according to the reference of this point. They are at the extreme corners. So I want them to be placed at this mid corners here. For that, again I am going to say display style changed and say finish first. Select the required frame to be edited. Go for this option, that is edit cross sections. We will edit the handle points. So as soon as you click on the handle points, these handle points will be displayed at each corner. So this locating points can be edited by clicking on any corner. So I'll select this point here. You can see these are oriented now with the center reference of this rectangular tubings. All the four sides are being positioned by using defined handle points. Say finish. Next I want to apply the tubings on this side also. So I'll select circular tubings for these two sides, the upper two sides. Select frame option again. Go for the browse option again. Go for the folder, go for round tubing. Select the size required and say open. So I've taken the smallest size here. Just click on the lines where you want to apply the structure and say OK. So you can see these tubings are coming. So these are circular tubings. You can see them. But we'll edit the feature and change it to square tubes only. Select path step and the shortcut list will be shown which were used previously. So I'll select this square tube only. Say OK. Say yes again. Next I want to apply the tubings on these tubes also. Say finish. Again go for frame option. If you want to take these tubings with the earlier tubes, you can go for that also. While selection, you just need to select all of them together. But I am taking it individually. Same size of square tubes on this sides also. Say OK again. And you can see this complete structure is being made now. Say finish. If you want to hide these sketches, you can hide them. I've hidden complete sketches now. And this is the structure we have made here. Now one more important thing. We were using only the standard structural size. Means the cross section sizes were standard and we were applying that sizes only. Suppose if I want to edit the cross sectional size of any structure, then we need to make the profile for that particular structure separately in part modeling. We need to save it in the folder of the frames and then we can apply the customized size also here. So if I want to change this rectangular tubing cross sectional size, I can change them. I'll make it little bit different size now. So this size first second was of we can expand this model tree here, and you can see the size. This rectangular tubing size was 40 by 20 by 2 as a thickness, length, width and thickness. So I'll edit these sizes and implement it on this structure now. So I'll make it in part molding separately and going to save it in frames. Then we are going to apply it on the structure. So this is the process for customizing the cross-sectional sizes of the structures. And we are going to move in part modeling now. Select ISO part, say OK. So I'll put on the reference planes here. Select the reference plane required, say sketch. Hide the planes again. So you just need to keep this note in mind. Whatever corner treatments are going to be there, that should be applied in 2D itself. We are not going to use 3D fillets and all. It is compulsory that radius should be applied in 2D sketches only. All the corner radius. So we'll take these dimensions as 38 by 32 by 2. So it is 38. This I'm going to take as 32, or else I'll take 30 only. Next we are going to go for thickness. Before applying thickness, we need to apply the radius at the corners. Select this option fillet. Make sure you have given this dimension between two sides instead of giving to line. So the corner dimension will not break there. Apply the radius size. I'll take this radius as, give the relation as equal on all the sides. And now we need to make offset. Before that, we'll fully define this sketch again. Then we'll go for the offset. So the thickness I'm going to take here is 2 mm. So I think we should increase the radius here. I'll take it 4. And then we'll go for the thickness as 2. For that I'm going to select offset. We are going to select here select chain. And the offset distance I'm going to take here is 2 mm. Click on the selection. Say accept. And you need to show the direction. So I'll take it in the inner sides. Say finish. And now this complete profile is been made according to the customized sizing for the rectangular tubings. Say close sketch, and just for formality we need to extrude it. Whatever size you extrude, it doesn't matter. I'll select both these sketches here. Say this option as select from sketch. Select these sketches, say OK. We need to drag it little bit. So at whatever direction you need to drag or whatever length you want, you can take it here. It is not going to matter at what length we have extruded. The structures will be applied according to the Weldment sketch, not according to the size of the extrusions. Hide this sketch, and we are going to apply the material here itself. So I am going to take here this material as stainless steel. After applying stainless steel, we need to say save, and we need to follow the path also here. So I'm going to select C drive, and in C drive I'm going to select program files. You can see the path is coming here. Just note down the path, and here only you need to save the frames, customize frames. So after program files, we are going to go for Siemens folder, solid edge 23 frames. So I'm going to select it in DIN only, and I am going to keep it at the upper side only. So whatever size I have customized, I am going to directly name by the size only for the tubings. So the size was 38 by 32 by 2, and that was rectangular tubing. Say save. So after applying the name and taking the custom sizing, we'll move to the previous assembly, that is Weldment structure. And here I need to change this frame, this upper horizontal frame of rectangular tubing. That was, I'll select this frame 1. So I am replacing this frame 1 with the customized frame there, which we have made in part modeling. So I'm going to select it, say edit, next select path, next browse, and we have saved the customized size in DIN. We are going to browse that size. You can see here 38 by 32 by 2, which I have made just now. I'll select this and say open. It will give a note. If I say OK, it will ask all the segments are going to be changed. Say yes. It is getting updated there. And now you can see the size has been updated here. These rectangular tubings are being updated according to the custom size. So in this way you can update the structure sizes also. So whatever cross section size of any structure, it may be circular tubing, rectangular tubing, C channel, I section beam, whatever standard tubings, you can update the cross sectional size and apply it here in the weldment structure. So next thing we are going to make here are these ribs at the corners. We are also going to make some support plates at the bottom, or else we can say end caps here, and that part should be made in separate part molding module, and then we are going to assemble it in weldments. So to start with, I'm going to take new part here. I'll say control new, say isometric part and OK. So whatever manufacturing parts we require to apply on the weldment structure, we are going to make them in part molding, and then we are going to weld it in assembly. So to start, I'm going to select sketch, say top plane. Next we are going to make it here. So I'll draw these two lines. We'll close the profile by the third line. I'm going to give the dimensions here. I'm going to take this as 40 mm. So I'm taking 40 by 40 rib here. It is also known as gussets. Say close sketch, and we are going to extrude it from the bit plane. Say extrude boss, select the profile to be extruded. Say OK. Select this as a symmetric axis, and we are going to take this extrusion as 10 mm only. Say finish and cancel. Next we'll hide this sketch, and we are going to apply the material. I'll apply here as iron. So after applying the material, we'll save this part. I'll name it as gusset and save it here. Say new part again. I'll select top plane only. We also need to consider the orientations by which we are going to apply these parts in the weldment structure. That's why I'm taking center rectangle from the top plane, as these plates will be seen from the top side only. It is not that any plane can be selected here. So I'll take it as 35 by 35. I'll say equal distances here. We need to hide the plane, say close sketch and extrude. So we'll take this extrusion size here as 10 mm only. We'll edit this size little bit. So instead of 35, I'm going to say here as 40, and we'll remove this equal relation, and we'll add this relation here as 30 mm. So it is 40 by 30 now. Say close sketch, say finish and cancel. Next we are going to apply the material here also. So I'll take it as galvanized steel. Say save. We'll add the name here as bottom support plate. So after making this gusset and bottom support plates, we are going to go in weldments, and we are going to call these parts here for assembly. So before assembly, we need to close the frame, as we were in close frame tab. So I'll select this option, close frame here, and we'll come out of this close frame tab, and we are going to go for the home option. Here you will see the assembly options. I'll say insert components here, and we'll call that part. I'll first call the gussets. We need to apply these gussets on these four corners. So for that, I'm going to select coincide mate first. This same, the mates we are going to apply are similar like assembly only, but the term we are going to use there is welding. So at present we are welding this part on that particular position. After saying coincide, I'll say coincide from this side also. Next we are going to say center plane mate. I'll keep the selection here as double only. You can see here the selection mode I have kept here is double. You just need to select two faces of the part to be mounted and two faces of the reference part along the center which we want to mount. For the center alignment, this gusset has been placed here. We'll see if we can mirror it or not. For that, I'm going to put on the assembly planes. I'm going to select a mirror option. Select the components to mirror, say OK, select the reference plane here, and you can see these gussets can be mirrored here. Say finish and cancel. We cannot pattern the gussets here. It is because the solid edge interface supports pattern only when the condition is that the patterns are made in part modeling also. That patterns can be reused here. So if we have made pattern in part modeling only, then we can pattern here. But we have made this assembly structure in Weldments itself. So we have not earlier made any patterns in part modeling. That's why we cannot use pattern command here. We'll mirror these two gussets on these two other sides also. Again, we'll select the mirror command. Just need to select the gussets and say OK. Select the reference plane and say OK again. Say finish and cancel. So you can see here, these support gussets are been added here. Now after adding these gussets, we can do one more thing. We also need to provide supports here also. So for that, I'm not going to add any gusset. We are going to make a structure only here for the support. So for adding this structure, we'll edit the 3D sketch again. We'll make one line here. Before line, I'm going to hide these frames. I hide these frame components. We'll hide the reference planes also here. And we are going to add one line here. So I'm going to add this line between these two vertical and horizontal lines. We'll start with this line and keep it placed it here. Provide the dimensions. So I'll take this as 70 mm. The other dimension also, I'll take it 70 only. It is completely constrained now, this sketch. Next we are going to mirror this line on the other side also. For that I'm going to select this 3D mirror. Select the option here, line, which we need to mirror. Select this option. Click on the reference plane and you can see this line is been mirrored on the other side also. Select both the lines here. Again select the mirror option, 3D mirror. Select the reference plane and you can see these lines are made on the other sides also. So after adding this line on all four sides, we'll say close 3D sketch. So for adding this structure, we are going to go in tools, select the environment option. In environment, we are going to say frame, and in frame, you are going to add the frame. Select the frame option, and we are going to add the same size tubing, that is 20 by 20 by 1.6. It is shown in the shortcut menu. Click on the lines and say OK. So here you can see these tubings are also added now, and they are getting by default trim according to the boundaries here. You can see here they are coming only till the boundary of this frame. Say finish and cancel. So we have added supports here also now. We'll hide the 3D sketch. Next we are going to add the support plates at the bottom we have made in part modeling. We'll hide the reference plane first. Say close frame first. Go to home, insert components and these bottom support plates. So here we are going to select the option that is assembly. Select the faces. So this part's top face is now been coincide with the bottom face of the structure. You just need to place it at the center using center plane mate. Select both the sides of this plate and both the sides of this tube. Repeat this again. Select center plane only. Select both the sides and also the sides of this tube. Parallel sides only. And this plate is been placed now. So now this bottom support plate is also been fixed here. We just need to mirror it. We'll go for the mirror option, mirror component. Select the component to mirror, say OK. Select the reference plane. Say OK again. Say finish. And now we are going to select both the components here which are to be mirrored. Again go for mirror option. Select the reference plane. But before that say OK and then select the reference plane. Say OK again. And finally these parts are mirrored on the other side also. We need to hide this reference plane here. This complete structure is been made now. You can see here. So in this way we can use the Weldment assembly for making particular type of structures here. We are going to take one more lecture for plate weldments. That will be the next session, in which we are going to see how the plates can be used as a structure for making weldments. So for that, follow the playlist and continue watching the next lecture, that is session number 30. Do like, share and subscribe the channel, and also comment us if any suggestions. Till then, thank you.